Hello everyone, welcome to Tan45Engineering. We are here with yet another video in our mastering data structures and algorithms in Java. Today's topic is linear search. So let's get started. Okay, so we have covered few of the sorting algorithms. In the searching algorithms, first one is linear search. It is the simplest searching algorithm. It works by iterating through each element of an array or list. You can go through the definition. I'll not go through it. If we found the match, we return the index or we return -1 or not found. Key concepts in linear search: every element is checked in a sequential manner. Efficiency, simple to implement but not very efficient for large datasets due to its time complexity. Of course, because for linear search we have to go through all the elements, the time complexity would be O of n. Okay, so let's consider an example. It's very simple. So input is 10, 20, 30, 40, 50. Okay, and linear search, as the name represents, is a searching algorithm. So we have to search an element or a key or target maybe. So let's say our target is 30. Okay, we'll come back to this. So for linear search we traverse through the complete array. Okay, so let's see how does the linear search work. You start from the first element of the array or list, compare each element with the target value. If a match is found, return the index of the element. If no match is found, return -1 or indicate the value is not present. Okay, so what we are going to do is we are going to traverse this input one by one. So first we'll get 10. We'll check, is 10 equal to 30? No. We move forward. Is 20 equal to 30? No. We move forward. Is 30 equal to 30? Yes. So we return index. So we'll keep a variable I that is running from 0, 1, 2, 3, 4. So at 30 we found on index 2 that target exists. So we will print the second index. Print index 2. But what if, let's say, our target was, let's say our target is 60. Okay, so we traverse through the array. We have the array 10, 20, 30, 40, 50. We traverse through the array. 10 does not match is 20, does not match, 20 is not equal to 60, 30 is not equal to 60, 40 is not equal to 60, 50 is not equal to 60. But we have reached end of our array, right, or end of our list. So we can return, we'll return simply -1. Okay, or if a string was being expected, so we'll return not found if a string was expected. Okay, so this is this simple. I'll just one second quickly show one more thing, and then the searching algorithm is almost done. Okay, so let's say, so how do we actually solve it? We have 10, 20, 30, 40, 50. Okay, we know that we have to traverse one by one, so we'll have a for loop. We'll define the conditions. Inside we'll check if array of I is equal to target. If it happens, we'll simply we can directly return from here the index, or we can save the index value. In the end, if the for loop ends and we do not find anything, in the end we can return -1. Okay, so simply we need a for loop and a if check. That's all that we need. Okay, so let's go to the code and let's solve this problem. Okay, so we'll say main function to perform linear search. One more thing, why do we call it linear search? Because we search on a linear scale one by one. So every element will be searched. First 10, 20, 30, 40, 50. So we had to check for 5 elements. That is the value of n. If the input increases, it becomes 10, 20, 30, 40, 50, 60, 100. Then the searching algorithm will take that longer amount of time, right? Or in the worst scenario can take that amount of time. So we'll have our time complexity will always depend upon n. That's why in the end we'll get the time complexity of O of n. And plus there is only one for loop, right? So let's solve. Perform the linear search. So we'll say public static. So linear search is the simplest search. This is the basic search that you can imagine. You have to go through each element and compare them. So public static int linear search will take the array int array and will take our target that we have to find if it exists or not, right? So we'll simply check for, we'll traverse through the array. So int I is equal to 0, I is less than array dot length I plus plus. Okay, now we'll check if the current element is equal to the target. So we'll check if array of I is equal to target. If it matches, we'll simply return I. Let me comment, return the index if found. So we found, so we'll return I. Otherwise, if we go through the complete for loop and we have not found the result, we can simply return -1 in the end. Okay, I'll comment for this as well, return -1 if not found. Okay, here we'll give our input int num is equal to 10, 20, 30, 30, 40, 50. So even if these values 10, 20, 30, 40, 50 are sorted, but even if they are unsorted, linear search will still take the same amount of time because it goes on comparing one element at a time. So it does not depend upon the sorting or unsorted of the values, right? Int target is equal to trgt, target is equal to 30, int result is equal to, we'll call linear search, will pass num and our target. Okay, it's linear search equal to. Okay, then if result is not equal to -1, that means we got the result. So we can simply print system.out.println element found at index, and then we'll print the index. What is the index? Index is mapped result. Okay, else if it does not happen, let me leave some space here as well, system.out.println element not found in the array. Okay, let's run it. Element found at index 2. If you go here 0, 1, 2, that is the index. Okay, let's say if we change the target value to 60 and run again, element not found in the array. Okay, I'll change it back to 30, run, and element found at index 2. Okay, so that is mostly all from our linear search. I'll cover the summary. From time complexity would be O of n. You can see it depends on there is only one for loop which depends on the length of the array, that is number of element, which is n. So O of n is the time complexity. Space complexity, we do not require any extra space, so it would be constant, O of 1. Pros, it is very simple and easy to understand, works on sorted and unsorted data. No additional space is required beyond the input array. Correct, right? We didn't take any extra space apart from the target. In fact, the target was given only, right? It is inefficient from the cons perspective. It is inefficient for large data sets because in searching, O of n is not the best time complexity for a searching algorithm. We do have better searching algorithms. So time complexity of O of n is worse compared to more optimized search algorithms like binary search, right? A binary search would be valid for a large data set as well, but the linear search can be performed on unsorted data as well. Okay, so that's all from this video, everyone. If you have any comments, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.